have all these protein molecules, right? The S protein is important to stop that so that it doesn't get infected into the cell directly. So what happens when it gets infected in the cell? It goes and releases its RNA and starts working on the normal, and it replicates. Okay, that's what we don't want. So that's just an introduction. So let's go pretty quick to. So what are actually antigens? So we want to know before antigens. So what our immune system is like, we have like two. There are various cells, but there is lymphocytes. We call it as lymphocytes. There is two types: B cells and T cells. Okay, T cells are like killer cells, which wherever pathogens. So I say the pathogen because it can be bacteria, it can not only just virus. Um, Whenever it goes, it kills that one. But in this scenario, it's not happening. It's not happening because the immune system doesn't know that, and even if it kills, the replication of coronavirus is so fast, and it does damage so quick that immune system is not able to reproduce the antibody for. So what is antibody? Antibody is just which neutralizes the virus. It neutralizes any virus or any pathogens. Okay. So what happens is it's simply not fast enough. Even if your immune system is good enough, it's simply not fast enough to stop this replication. The most important is replication, right? If one or two viruses is fine. I mean, when it goes, probably it might not do anything. It goes away. It goes, but most of the time it gets into cell. It's not necessary through just face mask or something. It can penetrate through any cell. Since it's in nanoscale, you can't even see it. Nanoscale, there is also theory based. It can also penetrate through skin and go inside. You never know. So, but it's not more likely, but there is a possibility too, because it's so. Since viruses are not a living organism, it's not a living organism, and it's a you can say it's, but it requires host to replicate. It cannot mutate itself. It cannot do anything by itself. It requires host itself. It gets into the body and gets into the system, and then it does the damage. Okay, so that's the main part actually. So what happens is immune system doesn't recognize this. Even if it does, let's say, so there are vaccination. There was vaccination also. The thing is, it's not working. The reason because it doesn't know. Immune system doesn't know which one to, and this thing happens so quick. The replication happens so quick that you don't even have the time uh, to neutralize that virus. And if it gains faster, then it becomes very hard to. If it's one multiplies, 2, 4, 6, okay, that's fine. But in the moment it goes beyond that, it immune system gives away. I mean, the immune system doesn't go. So here is the concept. Like, what you want to do, like antigens. Antigens is like kind of it's uh, it's made of, again, a protein molecule which doesn't harm the body. It doesn't harm anything. It's like a fake. It's like a fake. It's usually you see as polysaccharides and lipids, and it doesn't harm the body. But what it gives an alarm to the system, alarm to the immune system, that hey, something is invading the system. Hey, we need to stop this. Okay, so those are the antigen. It doesn't. For this, I have this good here picture. This is antigen. Okay, and these are the B cells. So let's say B cells or T cells. Let's imagine like a B cells, and these are, okay, you are harming the system, so we will neutralize you. So they will inject. I mean, they are like having this antibody to kill this, neutralize this um, antigen. So this is the antigen. This is not the real virus. Okay, so this is an antigen, and this, once it does, what happens is, say antibodies are the protein. So this is not working is because the reason, because it's replicating so fast. It's replicating so fast that an immune system is unable to recognize, even though if there is an antibody in the system, it is not able to beat that virus. It cannot neutralize because it's so fast, it's happening so quickly that it's not a, but what happening with antigen is, okay, oh, there is an foreign body, let's start it. So what happens, it neutralizes the target. So this is the antigen. Now what happens the next time, since it antigen, these are the B cells. Now these are the B cells. These are B cells because it's memory cells. You see the brain kind of thing here. So I told you, right? There are two. There is T cells and the B cells. T cells are directly neutralizes, directly kills or directly does. But B cell, what it does? Okay, this is the one which we saw. Oh, this is okay. So now we have to neutralize fast than before. So it remembers because it neutralizes antigen before. Remember this antigen? So what happens is okay, this is the new cell, and whenever the new this is the virus. Now this is the virus. What this B cell is saying? Okay, we already had this. Remember that one antigen? Okay, now let's attack this. That time, this B cells attacks this the virus. Okay, now this is the important thing. What we want to consider is body may not have that amount of antibody which we are looking for. Antibody is important because, and for this specific virus there is a different antibody, right? So this is the thing, like how it does, like this is now what B cells. Okay, now this we have already seen this before. Now this, when the real virus shows up, it starts neutralizing using antibody. Okay, so that's the whole point of this. And I have one screenshot here. So this is antigen. So this is antigen. This looks like coronavirus, but this is not the coronavirus. This is actually antigen. That is, it's just a protein molecule. It doesn't harm the body. It doesn't replicate. It doesn't do anything. It just to show up there for for the B cells to recognize it. Okay, oh, somebody is there to foreign objects. Let's neutralize. So this is why this antigen is important. So that's the reason for existence of the antigen, because to make other understand, to make B cells understand, okay, there is a foreign invader. We need to neutralize this target. So this is the antigen for coronavirus. And actual coronavirus you have seen, right? So actual is this is how it looks like with this protein and M protein. This is actual with single-stranded RNA. This has RNA, and the moment it enters into the host, positive RNA. So this is a negative RNA. It's Ebola virus was a negative RNA. This is the positive, single-stranded positive RNA. And what it replicates, this thing replicates so fast, so that's before entering into the system, it has to be neutralized. And once you put the antigen, so it recognizes, oh, it is foreign body, you need to neutralize, and you have to neutralize the target, and that's how it works. Now here's the question. Actually, there may not be sufficient, or there may not be antibody for this, right? So there are okay. Let me. I don't want to go more into detail, but there are like antibodies different for MERS and SARS. So this is SARS. Severe acute respiratory system. It's MERS is Middle East respiratory systems. Okay, MERS. This is SARS. Okay, so this is specifically antibody designed for SARS. For MERS, it's different. For that, there is one of my review paper. This is not a research paper. This is a review paper because there is already an there is already antibody for. Let me show you. So this is for the SARS. Okay. This is for SARS. For this might be helpful because since this is a novel strain of coronavirus. Okay, coronavirus was discovered in 1930. This is not new. And 1960, it was discovered in the human body. So it's not new. 1960, it's almost 40 years back, more than 40 years. So it's not new, but this is novel. The reason because it has a different genome structure. Okay, we don't want to go into detail. Genome is a completely different thing, but here it has completely genome structure. So that's the reason why this old antibody may not work. But for that reason, you need to see this, whichever the antibody which is there for this should be used. Okay, so this is more related to SARS. Okay, so let me do this one. So yeah, so there is two, MERS, that is Middle East Respiratory Syndrome, and this is severe acute respiratory syndrome. Okay, so this is more SARS because it goes into your lungs and attacks the cells into the lungs, and nobody knows at this point of time. I don't think scientists have figured out how death occurs into the, but it kills so fast. I mean, this replicates so fast that even before the antibody is produced, or even if you, let's say, even if you have antibody, the B cells has to recognize it. Okay, this is the foreign object, you need to neutralize this target. It has to be that fast than this, because this is so fast. It's, and once the replication it gets started, I mean, it becomes very hard for it. Okay, so this is my review paper actually. There are many other antibodies. This is one more antibody for SARS nucleoprotein. This is also protein molecule. Basically, this also neutralizes uh, the foreign pathogen. It might be bacteria, it might be virus. For this specifically, it is coronavirus. Okay, so this is another. So I gave an example here as a, this one as a, but for more understanding and more reading, probably you want to go to this paper. I will attach this review paper. This is actually my review paper. This is not the research paper, because there is already antibody for this. Only the clinical trials has to be done. Okay, the only thing is clinical trials has to be done for this one. So, and this is not ordinary, this is RNA vaccination. That means it's completely different. Most of the system works on DNA, but since this is little typical kind of thing, this genome structure is different, and since it's mutated coronavirus, COVID-19 mutated one. So there are three things which happened, right? In MERS, it happened in 2002, and again it happened in 2015. Okay, and this time it happened 2019, but this time it took all over the world. So all over the world is actually is in, and is this spreads not only just, see, this everybody says social distancing and all those things, doesn't matter. This spreads through air transmission. And I have that link. If anyone is interested to view that, I have this evidence on this. I'm not saying just like that. There is an evidence. It Of course, this transmits through saliva, it transmits through sneeze, it transmits through cough, it also transmits through air. Okay, so there was the news actually. I was viewing that news. There was a lot of coronavirus in air pollution. When there is a pollution, right? There was a lot of virus, and you never know when how it goes in the system, and it might stick to your skin, and probably once you remove this mask, it might go into, never know. So it's that dangerous. Okay, so, and at this point of time, only thing is immune system. Unfortunately, there are no drugs for for the viruses. Especially for bacteria you have, but this is a virus, because a virus is not much of research, but there is no drugs. Yes, there is for rhinovirus. We know rhinovirus as is cold, right? Whenever you get cold, that is caused by rhinovirus. There is a drug, but that doesn't help too much. But if you take too much of doses, of course, it affects your body too. But it neutralizes somehow, affects the mucus, your system mucus. But in this case, there are no drugs for this kind of virus. Okay. Any questions?
Participants, if you have any questions, you can just raise your hand so that you will be available for asking, and or you can also post your questions in the chat option so that Professor Mitra Manu can answer it. I'm so sorry, Mitra. Like I had a small internet lapse, and that's the reason why at the starting of the session I couldn't actually answer you.
Oh, okay, okay,
Yeah,
okay. Yeah,
so if you are having any questions, please put into the chat option, or you can also raise your hand. And I have a question, Professor Mitra.
sure.
Yeah, is this virus having relapse nature?
As this point of view, I mean, as this point of time, like we don't know much of the information, but yeah, probably it might contain, because there are a lot of theories going on. There are a lot of information. For me, it's to view that. I mean, it's like everyone has their own story. Like, it releases coronavirus from everywhere. So yeah, it might possibility that it might have that assumption.
Okay. And one more news we have been getting circulated that University of Oxford has been tied up with the Indian Serum Institute, and they are anticipating and expecting, the vaccination or drug by this September 2020. Is that possible? I have a very layman question that viruses doesn't have any vaccines according to me, but I don't know how come the proposals of this have been coming. Please add your point to this.
Uh, no, so okay, so let me get this point clear actually. Not all viruses have vaccination. Yes, that's true. But some of the virus have vaccination. Let me give you an example. Rabies. Rabies, it causes
Yes,
from the dog bite, right? You go to the hospital, take injection, right? So that's a vaccination, right? And another thing, let me give another example. Polio. Polio, okay, that occurs less.
bacterium. Polio is caused by bacterium, I guess.
Bacteria, virus, but yeah, you still have, you take that drops, something, okay. So yeah, not to answer your questions, not all virus have vaccination. That is true. But few of the virus like rubella, rabies, those have vaccinations.
Okay.
Okay. I'm not at this point of time. I don't remember any other, but there are vaccination. Of course, for rhinovirus, you're right. There is no vaccination because they're not worked on it.
That is
Rhinovirus,
what.
it's cold. Whenever you get cold, right? You sneeze, you get mucus, right? But it lasts for 1 week, 2 weeks, or sometimes till 3 weeks at the max. It's also works same. It replicates into the system. It actually goes into respiratory system and throat. It followed by cough. So that is caused that cold, the not flu, but the cold which is caused by rhinovirus. And
Yes.
yes, there is no vaccination for that. So to correct your statement, yes, all viruses don't have vaccination, but yeah, of course, if you research, I mean, if Oxford, of course, University has been researching on that a pretty lot, so probably they might also come up with some vaccination. But at this point of time, the vaccination is very really in necessity, because as of now, I think 200, more than 200 people, 200,000, more than
Yes.
200,000 people have been died because of this coronavirus.
See, according to many surveys, only because of lockdown, the numbers are getting down. If there is no lockdown, the numbers will be very high. So until and unless we don't get any drug or any particular remedy for this particular thing, if we go out of this lockdown, what would be the circumstances? Those would be like very dangerous, I guess. And coming to this vaccination process. As you mentioned, rubella or rabies, those are the viruses where we'll be having a death virus. I mean, a death vaccine, right? So, is that possible in the case of corona or COVID? Because this novel corona is really showing a strange behavior in different stages of life cycle. So they cannot I mean expect what sort of stage will be there in the next phase. And if they have find if they found some vaccine or drug for this particular stage, that will again turn into some other stage. Am I correct? And please add your inputs to this.
Yeah, actually, normally drugs won't work most of the time, actually. So, okay, so let me give an example. For rhinovirus, right, you use drug. There is no vaccination because vaccination is immunity. That means your B cells, your lymphocytes. Let me be, clear, lymphocyte. So it may be B cell, T cell, or probably there's a lot more cells which I don't know. There's a lot of cells that work for this, but lymphocytes which work for this, which neutralizes these pathogens, bacteria or whatever viruses, right? This has to work faster, or they have to get an antibody. It's like kind of ammunition, right? You don't have ammunition in your gun, you cannot fire, and if you cannot fire, then that means it's getting, it's getting more. So you're right. Your point is correct. Because of this lockdown, especially in India, it worked, and there was a lot less deaths. And if there were no lockdown, I'm not sure. Like it would be much more worst case. It's an exponential rise. It would be exponential rise. It's still an exponential actually, technically, but it's very less. As I told you that this coronavirus travels through air. It's not necessary. It has to be sneeze. It has to be cough. It has to be, and it can be anything, and it can stick to your body and goes through any part of the stomach. But yeah, mask is one of the way to control it. But you never know, right, when it got stuck and.
Yes.
Yeah, and yeah, to answer your second point, drugs. There, to be honest, as per my knowledge, there is no drugs for viruses. There are drugs for bacteria. There are no drugs except for this rhinovirus. Rhinovirus, but you use drugs only to control the mucus. When you get the mucus,
Exactly.
you use Koldak or something, whatever the drug you use. But that is the after effect of that virus, not to neutralize that virus, right? That's the after effect of this. So
Yes.
even if you're using drug, there is also separate concept, nanomedicine, which I'm editor in one of the journal actually.
Mhm.
Sorry, associate editor. So there are a lot of work which I review, and nanomedicine is something which shows promising technology, but I think that's way far at this point of time. Like that's doesn't at this point of time there's no but there's gold particles which help directly go into the place where the actually infected area, and use that drug gets released, and that's how you can neutralize that one. So drugs at this point of time, probably or probably not we can use, but drugs are used only to, as per my knowledge goes, only to stop after effects. Let's say you are having some respiratory problem, probably you might use drugs and that might stop, but that doesn't stop coronavirus. Coronavirus does it works, it damages the system, it damages the system.
Sorry to
But
interrupt. I have a point to add for this particular thing. This is a million-dollar question for many of us. Yeah. So we have been listening to this particular case numbers and all. They say that they have recovered from coronavirus. What does that recovery means? Recovery means that there is complete treatment. That doesn't, I according to my knowledge, recovered from coronavirus or COVID positive is getting recovered means, I guess they are only suppressed for the symptoms and they can actually fight against because their immunity will be boosted. But the corona which has been affected to their body organelles or whatever it is still alive. Am I correct?
exactly, you hit the nail actually. You just nailed it. You are only the whatever drugs or whatever you're using. You are using that only to stop that after effects of that coronavirus, but the virus is still there. I mean, only thing is the vaccination, which neutralizes. That's the only way at this point of time. Because let me give you another example. Varicella zoster, that is chicken pox.
Yes.
Chicken pox, once you get the chicken pox, is caused by varicella zoster virus. Once it gets into your system, okay, you use, okay, there might be vaccination or something, and but the unique property of that virus is like it remains in your system forever, in your body it remains for, once you get it, you get it. It's, if you are recovered from this, the virus is still there in your system, but it's only in inactive state. It doesn't harm, it doesn't, it stays wherever it is,
Yes.
but it doesn't
Once
harm.
the immunity system gets affected, then again there is a possibility that it will become positive.
Exactly. It just requires, immunity is there, okay, so it's silent. Once the immunity is low, it just reacts on it and it's get attacked. So yeah, you're right. I mean, all these drugs and all these things are only to stop the after effects. Let's say respiratory system. Okay, you have respiratory system. Yeah, you may stop that. Coronavirus, that is, drugs won't help. You would just in body immunity, B cells, T cells have to work on it, and that is antibody, which has to be there. And only single antibody won't help. Like probably you might also had a news, right, that they were doing some antibody research, but few patients were recovered, but not all of them,
Yes.
because it doesn't work for all the immunity, because some people immunity may be low, some people immunity may be high, some people immunity may be medium, so it doesn't work in all this. So that's the whole point. So you never know, like you need to give more antibody, you don't know, you have to also give antigen to make sure that B cells know that it's okay, this is the part of. So we don't know at this point of time, we actually really uh, not sure until this research. A lot of clinical trials has to be done. To be honest, clinical trials is very important for this one. So
And yeah, there are also components like we can also research on plasma, like as it's been done in other cases. Can that be like possible by collecting the sample of plasma from COVID positive patients and discovering any type of vaccine or drug? And another thing is like why no one is actually including stem cells into this particular research? I have a question on that.
So this plasma, yeah, plasma I've also seen, but mostly, yeah, also US was also researching on that one. But I think as of now, central government has rejected this one because it's not working in all of the patients. Yes,
Okay.
plasma is good, but it's plasma therapy. But thing is, it's working for some, it's not working for others.
Okay.
So the
And what
whole
about?
point, yeah, just want to few point. The whole point is you want to use whatever the medicines or whatever vaccination or whatever drugs before it gets into the system or before it gets into the host cell. Before it going to the host cell, you have to get immunity on this one. Otherwise, because the replication is so fast that um, you know immunity is not working.
Yes. So what about the stem cells? Can we make use of stem cells because stem cells have a lot of power when we concern with the immunity or regeneration things? So is that possible to make use of stem cells in this particular research?
Yeah, stem cells could be used. I'm not much aware on that one. Yeah, but the stem cells can be used. But again, the whole point is like to get uh, you have to get all the patients cured, like not just one or two. If it's working for one or two, it doesn't work. I mean, I'd not say completely it doesn't work, but it's again based on the immunity, right? How the body responds to that stem cells and how it works. So yeah, for some patients it might work, for some patients it doesn't. So that's how it's, I guess.
Okay. That's a very good information, and that was very interactive. Participants, if you have any questions, you can just post in the chat, or you can just raise your hand, and then and there you will be available to speak and ask your questions. If you have no questions, please, we will conclude this. And yeah, do you have anything to go ahead with the presentation, Professor Mitra?
Yeah, I have like so if you see this news, like I mean, I was just monitoring how many deaths, and so China has been using this some different kind of uh, therapy. From I'm monitoring this from past 2 weeks, they have zero deaths.
Yes,
And right, and these guys have recovered almost most of the patients, and only 600 patients are yet to be recovered.
yes, that a huge number out of huge number. That is very less.
Exactly. But the moment I read the other news, that how they are doing is that's not the way to do. Actually, the way they are using is either they are using the radiation method to neutralize that viruses, or they are using the melanin substance, which is the pigment actually, which fights for. That is a good thing, which fights. But what is happening? It has side effects, which is changing the color of whole body to
Skin
black.
body.
Okay,
Yeah.
right. So, and also probably there might be damages to liver stuff. If high doses are there, then it could be damage your liver. So,
So there is
um,
also a theory that they are having they like there is a proposal from US itself, like there is something fishy going on in China, as they wantedly have done all this. So yeah.
exactly, the intention was for me also. It's a big question that how come a level 4 laboratory, this is a level 4 virus laboratory, escaped the virus from this is a federal government lab,
Yes.
right? It's not a private lab. It's a federal government lab, and it escaped the virus. Oh, somebody forget the door closed and the virus escaped and it infected the whole world. I mean, that really it makes me hard to believe. And also, China says that okay, it goes to bats and it mutated from it, and so yeah, just Chinese bats came all over the world and infected everyone. That's really hard for me to take. So of course, there is a possibility that it travels through air current, but it infects all over the country is entirely a different thing. It's very hard for me to believe that bats infected to each and every one to the country and it spread to the others. So, and also to add the point, this is something which is re-engineered. This actually, um, and I mean this as per my knowledge, because I was going through a lot of articles and lot of things. It's a re-engineered because the genome structure of COVID, which happened in 2002 or 2015 or something around in China, was there, but none of the thing. It happened only in China, not rest of the world.
Yes.
Um, and it was not like transmission through air transmission or something. It was just normal transmission, and it was not affect too many people. But in this case, the genome structure was completely modified, and as per my knowledge, it's kind of you can remove that. It's shown you in the PPT, right, in presentation, that
Yes.
the protein structure, M protein, glycoprotein, and all those were modified and changed it, and they made it into completely new virus. That's kind of theory which is there. I mean, it's not like what I'm saying is based on what
There is an
article.
assumption and theory too.
Yeah, there are assumptions actually. It's an assumption, but I won't claim anything until it's been investigated and see what's going on actually. So
Okay. So any more questions to be added to the session from the participants? Please, if you have any questions, please put it in the chat option, or you can raise your hand. So Professor is always there to answer you. If there are no questions, I'll conclude the session.
Yeah, you can send me an email too. Email if you have any questions, you can send later through
Yeah.
my email.
Okay.
Um,
So,
I will.
shall we conclude the talk?
Yeah, I think I'm good. Yeah, we can conclude this. And
Okay, so before concluding the talk, I would like to provide the gist of this important and insightful session. According to Professor Mitra Manu, he had actually given us a very good presentation of how this COVID looks and how does actually this works and how does it actually goes with the reproduction and replication parts. And yeah, there are a few points to be highlighted. Among them, people who thinks that COVID patients are being treated, it's not the complete treatment that's been done. It's only boosting up their immunity, but it's not that they have completely done with the viruses. If their immunity system is again gets weaker, then there is a chance to them to become a positive again. So this is called relapse patient. And yeah, there are no drugs and no treatment and no vaccination for such viruses, and there are few cases of vaccination and drugs in the virus, as mentioned in rabies and rubella. But this particular virus, we could not actually get any type of drug or vaccination so far, because it is behaving very strange from cycle to cycle and stage to stage, and so it's getting tough day to day how to predict the next moment. And there is an assumption that this coronavirus, which has been actually known to the world from the country of China, is having the same or similar genome, but it is re-engineered as per the structures or protein structures that were showed in the presentation. So yeah, there are many assumptions, and the only thing what we can do is we'll have to boost our immune system. That is the only thing that we can do at this particular time. But you don't believe that there are drugs or there is treatment or there is vaccination, and if the lockdown gets over, the complete COVID is fine and we have conquered it. This is a very wrong assumption, and please don't bluff yourself and don't get bluffed by anyone. And you have to be safe until and unless there is a particular and specific end to this particular pandemic situation. And I would like to thank Professor Mitra Manu to add his points to this presentation. This is very insightful thing. And I would request Professor Mitra Manu to suggest our journals to your group members and to your colleagues and others also, so that we can have many publications, and we can go ahead with the successful path for the journey. And I also look forward to publish many more papers of yours in our journals. And yes, if you have any queries, you can just raise questions to me that will be passed to Dr. Miktamenu, and he can actually answer you, and those will be answered to your also. And yeah, at this particular pandemic situation, everyone please stay home, stay safe, as you are doing now. And you be very cautious in coming days, because we don't know what's going to happen. There will be a sudden a change overnight, and you cannot just fight against that if something happens to you. So stay safe. And Professor Mitra, please do support the journal as you're doing now, and please promote the journal to your members. And if you want to add something to this promotion of the journal, please add it on.
sure. Yeah, I will try to see if my one of my colleagues. I already invited few of my colleagues. So he invited a few of them were actually a little bit busy. So yeah, I will see that will invite more of my colleagues whoever is interested and pass them.
Okay, that's great. So yeah, I would like to convey my vote of thanks to Professor Mitra Manu and all attendees to spare your time for this valuable discussion. And yeah, everyone take care of yourself, and please have all the points discussed very seriously, and stay safe, because the world is in dangerous situation, and many of us are not knowing the exact or the depth of the danger. So please be safe. I am ending the session right now, and if you want to add anything, please you can add, Mitra Manu.
Yeah, just to add, he is right. I mean, this virus can travel through air. I mean, it's not necessary that if you're wearing mask doesn't mean that you are not infected. Probably it might stick to your body. You know that the protein structure which I showed you. One of the protein structure is responsible for sticking into the body, and the moment, and it lasts, I think, more than 72 hours or something. The moment you remove the mask, it might enter your system. I don't know. There are a lot of theories it can enter from any part because it's very minute. I mean, you cannot see it. It's nanometer. So it might enter anywhere. So going out at this point of time, even I stopped going out for office. Like office was pretty near 1 kilometer, but I will stop that. So going out at this point of time is not recommended. I mean, I would say no unless it's highly essential for food and something. Otherwise, stay at home, lock all doors. And, I mean, it's not even because the moment the air currents pass on, the virus might be still there in the air, and it lasts for I think more than 72 hours or something like that. So,
It's mostly like an airborne disease, so please.
exactly, airborne.
Yeah.
Yeah.
So yeah, if there is any other contact, like if you take HIV, then you should actually go and have a transfusion of blood or some other unsafe sex or something like that. That can be controlled, and that's there in our hands. And if it is some foodborne or waterborne, we can actually purify that. But if it is air, we cannot purify air, and that's what Professor Mitra Manu wants to tell. It's an airborne disease, so you don't know how which part of the air is polluted and which part you're traveling into. So yeah, always be safe. And people also doesn't know that this is an airborne disease. They simply say that yeah, around a COVID patient, some radius of the air is polluted and rest of the air is not polluted. It's not that. The air is polluted everywhere, and it's an airborne disease according to research from Mitra Manu. And there are many points that have to be stressed in day-to-day life. And please do take care of this particular thing. That is what Professor Mitra Manu wants to say. Am I correct?
Yes, yes. And if you want evidence, I'm more than happy to give evidence that it's an airborne disease. I'm more than happy to give because I'm not saying all this myself. I'm not making up. It's a research which a lot of people have done, and I'm giving reference for that. That it's an airborne, not just human to human. It can be through airborne also. So if anyone wants any evidence on that reference evidence, I'm more than happy to give that. So,
That's what. So all the points which have been stressed today are very important, and these are the points which will be actually taken on a lighter note by each of us. So don't ever take any point discussed in a lighter note. We are actually stressing this point because this is very important for us at this moment. I'm there, and I support all the points discussed with Mitra Manu. That's a glad and insightful session, Professor Mitra. Can I end the session?
yeah, sure. I'm good.
Yeah. Thank you all for your valuable time, and I'm ending the session. Thank you. Thanks, Mitra.
Yeah, thanks everyone. Thanks.